we have made it to the fourth unit today on the main goal of this unit is going to be dealing with logarithms and exponents. The way that logarithms and exponents relate to each other is that they are actually inverse functions. For instance, like adding 3 to a function is the inverse of subtracting 3 from a function. And so today I want to focus just on that, today and tomorrow actually, on finding inverse functions eventually, kind of warming up for that today. So suppose that someone was, I took this picture of Dexter weather this past summer. It says 33 degrees and thunderstorms. That doesn't make a lot of sense, does it? And you can see right here that I have everything in Celsius. So if you've ever traveled overseas, I have not had the opportunity to travel overseas, but a lot of places that you would go, especially in Europe, they use Celsius to measure their degrees. So if I am wanting to pack for a trip, I need to know what to pack for. If I just look at 33 degrees, I think that's kind of cold. But I don't know what this would be in Fahrenheit. It's probably pretty warm since it was summertime in Dexter, Missouri. But I would get there and have all these sweaters and sweatshirts and everything else, and I would see that I would need something that for me to dress for a lot warmer. And so the idea of going from Celsius to Fahrenheit is just an inverse equation that we would use to get 33 degrees into Fahrenheit. Hopefully we'll eventually do that over the next couple of days. So like I said, it's an inverse function. It's a one-to-one function, so it passes the horizontal line test. And then there's all of this about, I'm not going to read all that to you, all this about domain and range and F inverse and so forth. One thing I did like about this is that I am actually saying F inverse. And this looks kind of weird right here. I need to change that notation. It actually looks like F to the negative first power. So like F inverse of X is read F inverse of X. One thing to keep in mind is exactly this right here. And F inverse of X is not 1 over F of X. That is not a negative exponent. So it's just a different notation that we use for the inverse relation or the inverse function that we're going to be looking for. Okay. So going back to our toaster, remember, man, it's been a while back, maybe a couple months ago. Not the French toast, but the toast that we put into a toaster. We said that was some function of that. And that whenever it came out, it became toast, right? It has all these lines on there to become toast. What we're looking at doing now is finding an inverse relationship to this, a way to go backwards into this. So if I was to put the toast back into the toaster, if there was some way for it to come out to be just bread, that would be its inverse relation. Now, a couple things I want to point out with this is that you can see that whenever I'm working this with the green bread right here, this is my domain, my input, and we always call the output the toast or the range. And so whenever I'm working this in reverse, notice that my domain comes down here. It is now my toast, and my output, the bread that comes out, is going to be the range. Okay, so all of your domain and range is switching. What does that mean? Well, it means all of your inputs and outputs are flip-flopping from what they are. For X and Y, what that means is all my X and Y's are changing places. Okay? So more formally, I've got it written as this. The range of a function f of x is the domain of the inverse function f inverse, and the domain of f of x is the range. So if I had two sets up here, suppose that this was my, let me do it this way. I'm going to do like, this is a point, and suppose it maps over to this point. Okay. So whenever it maps over, let's just suppose that that is f right there. This domain right here would be the domain of f, while where it maps over to would be the range. However, if I'm working it in reverse and coming backwards, over here now, this becomes my domain. And at this point, and all the points in this set would be the range. Might be making that more confusing than what it is, so let's just look at an example. So we have a function, f of 7 equals negative 3, and f of 0 equals 10. I want to know what the corresponding input and outputs are for the inverse function. So my goal is to write this with this inverse notation. Okay. Remember, today all of my inputs and outputs are changing places. Okay, so what was the input right here? This 7 is now going to be my output down here in my notation. And what was the output is going to be now my input. Okay. And so what that means is just that I went from the point 7, negative 3 on my graph down to the point negative 3, 7 on the inverse. They're just flip-flopping places. So if I do this other one, f inverse of some number should equal your output. And so what was my output, this 10, will go on the inside. And what was my input will now be my output. Yeah, all I'm doing is just exchanging those two numbers. So as long as we're doing that, we're getting the idea down at least. So what if they give me two functions? How can I tell if they're inverses of one another? Well, the first thing I want to talk about doing that is actually it's kind of a form of a proof. It wants me to go back to these compositions that we just did, and it wants me to construct each composition separately, f of g and g of f. And what it says is that whenever I do that, I should get an answer of x both times. If I get an answer of x both times, then yes, they are inverses. But if only one of them fails, then deal's off. We do not have inverses. Okay. Let's try a couple of them. So let's do part A first. I'm just going to try my f of g of x. So if this is an inverse, I should get x down here. Okay. And then I'll work it again, and I'll do g of f of x. Okay, so I'm going to start with my direct substitution, just plugging in my g of x. Up here it is 1/3 x. Okay, now I'm going to take that 1/3, plug it in for the x on my f of x, and I get 1/3 x cubed. Well, 1/3 cubed is 127 x cubed. That does not equal right there. Therefore, they kind of look like they would be inverses. You get the x cubed and 1/3 x, but they did not come out to be equal like this. So this would just be a big no. No need to even worry about this guy because I've already got an answer other than x on this. So this would be a no. Well, hopefully part B is a yes, so we can see what's going on. I meant for the square root all the way over. So we have f of x equals, oh, sorry, I want to do f of g of x. Just keep my blue going. F of g of x. F of, let's see, g of x. So I'm going to do my direct substitution there. Take the x squared plus 1 and plug this into my g of x. Now I'm going to take this x squared plus 1 and plug it into x. So the square root of x squared plus 1. X is minus 1 happening behind the x. So the minus 1 comes in. So square root of x squared, yeah, square root of x squared is just x. So I'm good there, but it doesn't mean that they're inverses just yet. I need to come over and do g of f of x and see if that gives me x as well. So I'm going to do my direct substitution. This is square root of x minus 1. And then plugging this in for g, I get the square root of x minus 1 squared plus 1. So looking like the answer is going to be x down here, just make sure you show each step as you go. So the square root and the square, they cancel each other. X minus 1 plus 1, yeah, I get x, give them equal. So those two are inverses of one another. Okay, that will hopefully mean more to us as we go through the next couple of weeks. Let me try to draw one of these. I think I'm going to pause the video for a second and get it drawn up there just so I make sure I'm getting everything done correctly on it. I had to do a little bit of erasing there, so I think hopefully I saved you some time. So I'm wanting to find f of 4, f of -1, f of -8. We have done this. We did this a couple months ago when I introduced functions. So f of 4, 1, 2, 3, 4. Count over to 4, and it comes down to -2. Okay. We've done this. I can fill in the other ones, f of -1, 1, 2, 3, 4. And there are a couple of these in your homework. -8, I think I have 1, 2, 3, 4. I think I hit them. But the question comes in, what happens whenever I want to reverse this? Okay. We saw earlier today that if I was to change it around, and then suppose I was to ask f inverse of -2. Remember, this changes to my output. So instead of going on the x-axis to find 4, or in this case -2, I'm going to come up. I'm going to come down to -2, and I am going to come over and find what x value relates to 4. So as you can see, this is still what we did on the first example today. We just have to come up with our own function value. And so all of the inverses of this would hold true. Let me try to come up with one we haven't done. Let's do like, I have a really good one on there. I hit all the good ones. I'll just make one up. We'll just try f. Oh, I missed that one for some reason. F inverse of -8. Okay. It's be kind of hard because we didn't get a -8 over here, right? So f inverse of -8, I would need to come on down my axis down here to -8. And again, this was my output. I'm working it in reverse. This is my f function. Right? I would have to come over 1, 2, 3, 4, 5, 6 places to get it. All my x's and y's are switching. That's kind of the gist for today. Having this down will make tomorrow and being able to find inverses go a lot easier.